Yes, good evening to you all. Welcome back to another beautiful session on control system subject. In this presentation, I would like to bring you a very important concept of finding the transfer function of a given control system using signal flow graph method. By the way, this is lecture number 8. Lecture number 8, in which I am going to explain you signal flow graph method. It is signal flow graph method, also called as SGF method of finding the transfer function of a given block diagram. So, what is a signal flow graph? Signal flow graph is nothing but it is another beautiful pictorial representation of any given control system in the form of signal flow graph. Signal flow graph is nothing but it indicates or it describes about the flow of the signal. Here the signal means it could be the input signal, as we have seen in our last presentations, that is nothing but our R of S. R of S is nothing but our input, and similarly other than R of S we have one more signal is also, it is nothing but a feedback signal, which is nothing but we are taking a part of output signal, portion of the output we are taking back and feeding to the input signal. So basically you have two types of signals, you can say. One is input signal, second is nothing but your feedback. These are what signals means as far as this topic is concerned. Therefore, how the signal flows in this particular block diagram, how the flow of the signal is represented is nothing but signal flow graph. Means that how the R of S is flowing through this diagram, as well as how the feedback signal is flowing through. The representation of the input signal R of S as well as the feedback signal is nothing but signal flow graph method, signal flow graph. Right. So the objective of this topic is again to find out the transfer function, as we have seen in our previous topic of finding the transfer function using the block diagram reduction method. The object is same as the block diagram reduction. Okay, so as we have seen in block diagram, there we have seen some set of rules, nothing but the block diagram reduction rules. With the help of the block diagram reduction, we have obtained the transfer function for the given block diagram. In the same way, in this signal flow graph method, you have four important, very beautiful steps to find out the transfer function of a given signal flow graph. I am once again repeating the same. You have beautiful steps of 4, means 4 steps are there. So first of all, you should identify what are these 4 steps. Step 1, what is step 2, what is step 3, what is step 4. So these collectively, if you identify and if you recognize what are these step 1 to step 4, then your problem will be solved. And one more important topic that I would like to highlight here is that the signal flow graph method is a very excellent topic, and it is a very, very important topic, especially as far as your competitive examination is concerned. Most of the questions you can expect from this topic only than your block diagram reduction, especially in competitive examinations like GATE examination and UPSC ESC examinations and many other state and central technical competitive examinations. You will be asked the questions from this signal flow graph method only. Therefore, so carefully you follow, definitely you will enjoy this class. Now I am going to explain you what are those beautiful steps. The step 1, I am going to explain you what is step 1. Step 1. Step number 1. What is the step number 1? Actually, these steps are in the nature of the theoretical concept, but afterwards, while explaining the problem, you definitely will understand how to understand these steps and how these steps will be applied to the given problem. By the way, what is step number 1 which is to be applied for the given signal flow graph method? Step number 1 is nothing but in the given signal flow graph. In the given signal flow graph is nothing but again the flow of signal from the starting point to the end point. Obviously, the signal will start from certain point, that is nothing but the originating point, nothing but your initial point, which is nothing but your R of S, which is nothing but your input. And definitely it should reach to the final destination, nothing but we are considering it as C of S. Therefore, so starting from your input, reaching to the output, the signal is how the signal is represented, how the signal is flowing, means it travels in a forward direction. It travels towards the destination. It travels from the initial point to the destination point in a forward direction. Means that what the in this step 1 we are going to identify, we are going to find out the forward paths. So the number of forward paths, the number of forward paths, normally the forward paths are identified by the letter capital P. The number of forward path with their path gains, with their path gains, with their path gains. Okay. For example, let us see, for your convenient, I am explaining you that. So I have starting point here, let us say the city Hyderabad. You are going to reach, your destination is to reach Delhi. So that is your destination. Let us call it as your input R of S, and let us assume that your Delhi output, I mean destination as C of S. In between there could be so many intermediate stages will be there. I mean another intermediate cities. Our objective is to reach Delhi from Hyderabad. What are the possible ways that you have? Normally, obviously, you can reach the Delhi from Hyderabad by bus, and also you can reach from Hyderabad to Delhi by train, and obviously again you can reach from Hyderabad to Delhi through air. How many paths are there? There are 3 paths. Each path is directed as a forward direction. Let us see, I will explain for your better understanding. See, the arrow mark is represented in the forward direction. Let us say this is path number 1. Let us say this is path number 1. This is by bus, you can say. This is by bus. By bus. So this is Hyderabad, this is Delhi. These are the intermediate stages. Stage 1, this is stage 1. This is another city. Stage in the sense city 1, some intermediates, and stage 2 and are okay. This is 3 and then 4 and finally you have 5. Okay, this is first one. So if you travel by bus, so your flow of journey is like this. Your flow of journey. So from first to second, or otherwise you can consider it as first and you can treat it as the second. This is third. This is fourth. Okay, this is 5 and this is the sixth one, last one, sixth one. Let it why? Because we are considering the input R of S as the first stage itself. Therefore, you have 6 stages from starting to ending. Is it not? Then, so from first to second, you may have some gain G1, let us say. From 2 to 3, you may have gain G2. you may have 3 to 4, some G3, and 4 to 5, some G4, and 5 to 6, again G5. These are the gains you have to consider. Now, what? As per my step, the number of forward path means if you consider this, I am explaining by taking the journey by bus. Nothing but the first possible way, nothing but your first forward path. That I am taking it as P1. P1 is the first possible way from Hyderabad to reaching Delhi. First possible way, first forward path, P1. Okay, P1. Then what are their gains? Forward path along with their path gains. Path gains means you have to take the multiplication of G1 into G2 into G3 into G4 into G5. All the gains which are available on the signal flow graph shall be multiplied. G1 into G2 into G3, G4, G5. Therefore, G1, G2, the G3, G4, G5. Is it not? G5. This is what the first forward path along with your path gain. This is the first forward path. Let us say you have one more path, that is by train. It may travel some another route covering other stations, other cities, but finally it reaches to Delhi. Okay, then in the same way as we have represented in this case, again in that case also you represent the gains, some other gains. Okay, then you can take it as path 2, P2, and that is equal to, what is the path gains? Nothing but the product of each gain available on that route. That is what? P2. In that case it is P2, and you have to take the product of each thing, each gain. And similarly, path 3 means it go by air, like that. So what are the gains available in that? So P3 is equal to all those gains which are available in that route will be multiplied. That is what? Path 1, path 2, path 3. That is what the meaning of the step 1. Number of forward paths we have to identify, and you have to take their path gains also. Okay, what is path gain? Path gain means, so it should go in the forward direction only, and the flow should not touch each node. These are called nodes. This is first node, second node, third node, fourth node, fifth node, and sixth node. All these points are called as node. So each signal should touch to each node only one time only. It should not touch twice. If it touches twice, it is not treated as the forward. It is like that. So that must be in this form only. Signals should start here and it should reach the destination like that, forward direction only. I think you understood what is forward path along with their path gains. That is the step number 1. At this moment, you just remember this much only. While solving the problem, you can definitely will understood the concept of this also. So as per the signal flow graph method, the step number 1 is nothing but identifying the number of forward paths which are available in the given signal flow graph. Then we have to identify those paths along with their path gains. That is the step number 1. Now, what is step number 2? Step number 2 is nothing but identifying the number of individual loops in the given signal flow graph. Identifying the number of individual loops. Step number 2. Step number 2. What is step number 2? Identifying the number of individual loops. The number of individual loops with loop gains. Normally, the individual loops are identified by L, the letter L. Here, it is nothing but, now obviously, you can write it as L suffix K. where k is equal to 1 to n. L suffix k, where k is equal to 1 to n. Say for example, in the given signal flow graph, suppose, is there any individual loop? What do we mean by loop? Loop is nothing but it is the path that should start from a node and it should reach to the same node. That is called a path. Okay, it should start from a node. It is a path that should start, means say for example, here is a node, here is a node, here is a node. Say for example, this is R of s. For your understanding, this is C of s. Let us say R of s to, this is the first node, this is the second node, this is the third node, you can say. So 1 to 2, I have something gain G of s, or you can say G1 of s, or 2 to 3, say G2 of s, let us say. And 2 to 1, again I have some path like this. It is say H of s because it is closed loop. In closed loop, the gain will be represented by the letter H of s, or you can say H1 of s. And similarly, 3 to 2 also, I have another loop H2 of s. This is H1 of s, H2 of s, for example. So this is the given signal flow graph. In this signal flow graph, if you see, for this particular step, individual loop is nothing but, say, if you consider this particular, so this signal starts from node 1 and it is going to up to 2, again from 2 it is coming back in reverse direction and reaching to 1, means it means that this is forming a loop, closed loop. It is a forward direction, and again from here it is coming reverse direction, thereby it is forming a closed loop. This is one loop. That is nothing but means, similarly, if you consider 2 to 3, between node 2 to 3, again here the G2 of s is going to forward direction from 3 to, and again 2, it is coming reverse direction, from 2 to 3 it is forming another closed loop. Is it not? Therefore, thereby you have two independent loops. Here this means that this indicates k is equal to, in this case, k is equal to 2. Nothing but k is equal to 1 and 2. 1 and 2. That means that how many independent loops you have? L1 and L2. You may have L1 and L2. What is your L1? What is your L1? L1 is nothing but L1 with their gain also you have to write. So what is the gain? Gain is, what is their loop gain? Loop gain is nothing but the gain, the product of gains which are available on that path. It is nothing but G of s into H of s. That's all. G of s into H of s. That's all. That is your L1. And similarly, this is L2. L2 is equal to G2 of s into H2 of s. For this example, that's what the meaning of the second step number 2. Identifying the number of individual loops. Likewise, you have to, the signal flow graph will be given like this only. For the given signal flow graph, you need to identify the independent loops, and you have to mention the loops along with their corresponding loop gains. This is how you have to identify. That is what your step number 2. What we have seen in step number 1, you are finding out the number of forward paths with their path gains. That is step number 1. What is step number 2? The number of individual loops with their loop gains. Okay, sometimes in your examinations, maybe 1 loop will be there, or 2 loops may be there, or 3 loops may be there, or 4 loops may be there. No problem, but you should apply this rule and you can identify the loops all. Okay, this is what your step number 2. And now, what is step number 3? Step number 3 is something different than these two, but it is very easy also, nothing to. Step number 3. What is step number 3? So, in step number 3, before explaining that, just I will explain the small diagram for your better understanding. Let us say, for example, this is the given signal flow graph. Node 1, node 2, node 3. Is it not? And same as I have explained in previous, G1 of s, this is G2 of s, let us say. This is your loop, it is H1 of s, let us say, H2 of s, let us say. So, As per step number 3, what we are going to find out is that what step number 3 describes is that identify the number of two non-touching loops and three non-touching loops in the given signal flow graph diagram. Understood? What we have to find out? Identify two non-touching loops and three non-touching loops and four non-touching loops and five non-touching loops and so on, so like that. What do you mean by two non-touching loops? Two non-touching loops are nothing but in the given signal flow graph diagram, you have to see that is there any two individual loops are there and which are they should not touch each other. Okay, two non, so identifying, I will write for your better understanding. Identify two non-touching loops. Two non-touching loops and three non-touching loops. Okay, two non-touching loops and three non-touching loops in the given signal flow graph, SGF, signal flow graph. Two non-touching loops. There must be two loops which should not touch to each other. That is the meaning of this. Similarly, what is three non-touching? Three non-touching in the sense, in the given signal flow graph, there should be three individual loops and they should not to touch each other. Means two loops must be there, they should be somewhere without a common point, without a common node. Similarly, there should be three individual loops and they should not have common node. That is the meaning of it. If they are like that, then you may have some value for that. If they touch, then the value is something different. That you can understand while solving the problem. Okay, right now you just at this moment right now you just remember this much only, that is two non-touching loops. Two non-touching, you should always remember non-touching. Two non-touching means there must be two loops, they should not to touch each other, means they must be separated. Similarly, in three non-touching, that means that there should be three separate individual loops must be there and they should not touch to each other. Three are different. If these loops are there in the given problem, how to solve means you definitely will understand while solving the problem itself. That I will better explain while solving the problem only. So right now just remember, in step number 3 you have to find out, is there any two non-touching loops or three non-touching loops are available or not. That much only you have to identify. Now coming to step number 4, this is the last and very important final step of this finding transfer function of the signal flow graph method. That is the step number 4. Step number 4. What is the step number 4? Step number 4 is nothing but this is the final step. This describes about the transfer function of signal flow graph method. This step describes about the formula, means finding the transfer function. This defines the transfer function is equal to, directly you can write the formula only. The transfer function nothing but TF. Your TF. What is TF? TF is equal to, this is 1 by delta sigma k. It is p suffix k delta suffix k. This is what your problem. This is what your formula. As per the signal flow graph method, the step number 4 describes this. TF, transfer function of given signal flow graph method, is equal to 1 by delta sigma k. K is equal to, again here 1 to some n, p suffix k delta suffix k. That is the formula. And most of the time this transfer function can also be called as Mason's gain formula. Remember that. This transfer function can also be called as Mason's Mason's gain formula, because the scientist Mason, his name is the Mason, he who was developed who was invented the signal flow graph method of finding the transfer function. That's why this step number 4 is named after his name only. Okay, this is called Mason's gain formula. Okay, 1 by delta sigma k is equal to 1 to n pk delta k. Okay, so then what is pk, what is delta k, what is delta? These things we must able to know. Here pk is nothing but this is what you were from first step. What we have seen in the first step, number of forward paths, means here pk. Say for example, if you have your k is 2, k is equal to 2, means you have number of forward paths 2. Okay, I am erasing here and I will explain. So say for example, if k is equal to 2, for k is equal to 2, what you will have? So for k is equal to 2, you have this formula like this. I will completely erase so that I can. For k is equal to 2, your transfer function is equal to, it is 1 by delta sigma k is equal to 1 to 2, let us say, then it is pk delta k. This means that 1 by delta, for k is equal to 2, this expression can be expanded like this: p1 delta 1 plus p2 delta 2. That is the meaning of it. For k is equal to 2, this expression can be expanded like this: p1 delta 1 plus p2 delta 2 by delta. What is p1? P1 is nothing but your first forward path. As we have seen in the step number 1, P1 is nothing but your first forward path. What is P2? P2 is nothing but your second forward path. Again, P1, P2 we are finding from your step number 1. These are nothing but your forward paths only. Then what is delta 1? What is this? What is delta? Delta 1 is nothing but the value of delta which is associated with the first forward path. Delta 1 is nothing but delta 1 is the value of delta with respect to forward path 1. And similarly, what is delta 2? Delta 2 is nothing but the value of delta with respect to the forward path P2. Like that. Okay. Then, so how to find out delta 1? It is very simple. So for example, let us consider this one. You have two nodes, node 1, node 2, or otherwise you can take node 3 also. Okay, then you have here g of s, g1 of s, let us say it is g2 of s, and then say for example here h1 of s is there, and then say for example here h2 of s is there. Is it not? Say for example, for this case, let us say how many P1 are there? For this example, how many forward paths are there? Can you imagine? Can you able to see now? Can you answer me? How many forward paths are there? If you see from starting point to end point, you have only one forward path only, because the arrow mark is going forward direction from 1 to 2, and 2 to 3 we have one more forward direction, because these two are in forward direction. Therefore you have only one path, that is P1. That is, what is the gain? What is the path gain? G1 of s into G2 of s. That is nothing but G1 of s into G2 of s. Only one forward path you have. Then what about this loop? Is it forward path? Can we take this as forward path? No. Why? Because if you see here, the arrow mark is coming reverse. If you see, if you want to go in this direction, it is coming reverse direction. Therefore, you cannot go in this, because the arrow mark is reverse. Therefore, it is not forward path. It is not a forward path. Similarly, from here also, you cannot go forward direction, because it is coming reverse. Therefore, okay, it is coming reverse. Therefore, you cannot go forward. Therefore, these two are not forward directions. Only this, only you have one forward path only. Okay, very good. Then what is delta 1? Then in this case, in this for this example, you don't have P2. Only P1 only, P1 only will come. Then what is delta 1? Delta 1 is nothing but corresponding to P1, if there is any loop, okay, corresponding to forward path P1, if there is any loop which is associated with the first forward path, okay, if there is any loop, closed loop, which is touching to the first forward path, if okay, if there is any closed loop is available and that loop, if it is touching to that forward path, then your delta 1 value is 1. Remember that. That is the meaning of it. Okay, for the given forward path, for that forward path, if there is any closed loop is available with respect to that path, and that if that loop is touching to that forward path, then the delta 1 value becomes 1. If it not touches, then something other value will come. So that you will understand while solving on the similar kind of example only. Otherwise, you will feel little bit confused. Okay. Similarly, P2. Say for example, you have another forward path P2. Then for that P2 only, you have to consider P2 only. Forget about P1. Only P2 you have to consider, the second forward path. If there is second forward path, then in the given signal flow graph, is there any closed loop which is touching to that forward path 2? Then in that case, delta 2 value becomes 1. This thing you will understand while solving the problem only. Okay. Likewise, this is the meaning. Then what is the delta? Delta is nothing but, I will explain you here. It is very easy. What is delta? What is delta? Delta is nothing but, the value of delta is something like this. It is 1 minus sum of gain product, sum of gain of individual loops, sum of gains of individual loops. You have minus here, no? Next you will have in a second parameter plus will come. Okay, 1 minus sum of gain of individual loops plus sum of gain product of all the possible combinations of two non-touching loops. Okay, then minus will come, and same definition, sum of gain products of all the combinations of three non-touching loops. What? 3 non-touching loops, and so on and so forth, like that. Then it comes plus and so on. So this is the meaning of delta. Looking something, but it's very easy to. So delta is equal to 1 minus sum of gain of, this means, obviously this means that it covers your step number 1. I think step number 2, step number 3. That's all. This delta can be identified. From your step number 2, okay, and from your step number 3. You will find out something, na? In step number 2, what you will find out? What you will find out in step number 2? Number of individual gains, L1, L2, L3. So nothing but here sum of gain of individual loops nothing but L1 plus L2 plus L3 if three individual loops are there. That's what from step number 2 your L1s will be summed up here, and then in step number 3 you will find out two non-touching loops and three non-touching loops. If there no, the same you will apply here, is it not? This is what the formula. Therefore, so with this, I would like to conclude this presentation here, and in the next session, we will see some more examples on the signal flow graph. Then you will better understand about these steps. Okay, thank you very much, and we will meet in the next presentation. Thank you very much.